Okay, question number 4 on the intermediate algebra exam. We're taking the absolute value of negative 6p plus 3. And that's greater or equal to 15. So again, we're going to have two cases. We're going to treat it the same way, this equation, the same way we treated the equation for problem number 3. We're going to have two cases, so we take negative 6p plus 3, and that's greater or equal to 15. And our second case is going to be negative 6p plus 3 now is less than or equal to negative 15. So we did the same thing that we did here in problem number 4 that we did in problem number 3. So we just solved the two-step inequality. We subtract 3 from both sides, inverse operations, and we get negative 6p is greater or equal to 12. Dividing both sides by negative 6 gives us part of the solution. Negative 6 over negative 6 is just 1, so p is greater or equal to 12 divided by negative 6, which is negative 2. So p must be greater or equal to negative 2. Okay, case number 2. We're going to again subtract 3 from both sides. Inverse operations again. That brings down negative 6p, which is less than or equal to negative 18. Okay, so now we have a one-step inequality. We're just going to divide both sides by negative 6. But guess what? This gets flipped again. The less than or equal to becomes greater than or equal to. So p must be greater or equal to negative 18 divided by negative 6, which is positive 3. So there's our solutions, or our solution. And we can simply check that by graphing it and just plugging in numbers and see if it works. I always do this as a check for inequalities just to make sure I didn't make a mistake. So here's 0 on the line P, here's negative 2, and here's positive 3. Okay. Let's see that. Oops. Let me bring that up a little bit. Okay, so here's the line P, excuse me, negative 2 and positive 3. And we're just going to plug in some numbers. If we plug in 0 into our original inequality, then negative 6 times 0 is 0, and 0 plus 3 is 3, and the absolute value of positive 3 is not greater or equal to 15. It's actually less than 15, so it doesn't work. If we plug in any number between the interval of 2 and negative 2 and 3, it shouldn't hold true. But however, all numbers less than, or excuse me, oops, we forgot to flip this sign too. Remember, when I'm dividing by a negative number, I have to flip the sign. I just caught that. Do you see that? Okay, so I have now p is less than or equal to negative 2. P is less than or equal to negative 2, so I had to flip the sign. Remember, I didn't flip the sign when I divided. So if I plug in negative 2 to the original equation, negative 2 times negative 6 is positive 12, and positive 12 plus 3 is 15, and 15 is equal to 15, so it holds true. So negative 2 holds true. So let me regraph that. And if I plug in any number less than negative 2, it should also hold true. Likewise, p must be greater or equal to positive 3. So if I put in 3 for p up here, then it should hold true. So negative 6 times p is negative 18, and negative 18 plus 3 is negative 15, and the absolute value of negative 15 is positive 15. That makes the inequality true. And if I plug in any number greater than 3, it will also hold true. Okay? So here's what our graph looks like on the number line p. Thank you.